Hello, everyone, and welcome to our third module of Bioinformatics Bootcamp, R for Biologists. Now, we're actually going to start with a quick recap of last time, and in particular, we're going to get to a data structure that we didn't have a chance to talk about, which is the data frame. So data frames are a fairly complicated structure when you talk about it at the level of coding, but to most scientists, and in particular most biologists, it actually ends up being one of the most comfortable data structures to work with, because a data frame can really be conceived of as the same thing that you see when you do Excel. It is any sort of tabular data in R where you see rows and columns that contain observations and features. And so what does that mean? Well, to give a more simple example and to show you how you can get something that looks like this in R, I'm going to actually just jump over to RStudio now and give you the iris example. So you should all have this open. This is the module 2, and this is the one that you should have downloaded today. So hopefully you've all got this open. Go ahead and open up module2 underscore part2.r. So if you just click on this right here, it'll open it up in the editor view. And we're not going to do a whole lot here. I just want to show off one very popular data frame to use in R, which is called iris. And a little bit about how you can access it. I'm going to ask a couple questions to challenge you a bit and see if what I'm saying is making sense. Okay, so first thing that we'll do is we'll view iris. Now, view is a command that you can use in RStudio. It doesn't work in base R as far as I know. And it's a command that allows you to take a data frame and visualize it the same way or a similar way to how you would do it in Excel. So iris is already loaded into our environment. Even though you don't see it here, it's actually there. And so let's go ahead and view that iris data frame. All right, so all I did was hit Control Enter. And so hitting Control Enter on Windows, I think it's probably Command Enter on Mac, allows you to run a line at a time. Okay. So what do we see here? Well, we see a data frame that includes information about irises. And so some biologists at some point in the past went out and they measured the sepal length, sepal width, petal length, and petal width of several irises from different species. And so they collected this data, and we can see here, this is actually what I was referring to before. Every row in this data set is one flower. So every row is an observation. Every column is something about that flower. It's a feature. So we've got, again, rows, observations, columns, features. And this is typically the way that we represent data in a tabular form with any sort of data science or when we're working in R or even in Excel. Okay, so the nice thing about your ability to see this in RStudio is that you can actually do things like you can filter the data set, you can sort it, and you can even search it. So let's say I'm looking for Setosa. I can easily search for all the observations where I found the word Setosa. So it's a very powerful tool. Certainly is not going to replace Excel for you, but it's a nice way to be able to see your data while you're working in R.
How did you get to iris?
So you just go ahead and run this line number 2 here.
Oh, okay, I see.
Yeah. And so, yeah, again, I just put my cursor anywhere on line 2 and you hit Control Enter.
Yeah.
And that should do it right there. Yeah. Okay, so let's talk really briefly about how you actually access data while it's in a data frame and manipulate it. So going back to the PowerPoint, which is right here. Okay, so data frames are similar to Excel sheets. They are 2D arrays, which can hold numeric, character, and Boolean data. They also have column names. So this would be an example of us constructing a data frame called my_df, and it contains 2 columns, students and grades. And it contains several observations. So for students, you've got Jimmy, Alice, and Susan, and then you've also got the corresponding grades for each of those students. Again, rows would be the students because those are the observations, and columns would be grades and students because those are the features of those observations. If we actually do this in R now, I know I didn't include this in here, but I think it might be nice to actually show someone writing this. So I'm going to construct this the same way I just did it in the PowerPoint, my_df. Now that arrow is assignment. So I'm saving this all to a variable. All right, so we said data.frame. That is the constructor. That is a function that allows you to build the data frame object based off of vectors, which again, you can see here. So these are our vectors. They represent our columns. And then students and grades are the names of those columns. So that might not make total sense at first, but hopefully as we do this in RStudio, it will feel more natural. All right, so we had columns. The first one was students. And students contains the vector Jimmy, Alice, Susan. Okay, so that is our first column. All right, just a really quick question here. Feel free to put it in the chat. Can I have a data frame that only has one column? What will happen if I try to run this? Does anybody know? And you can actually try running it yourself if you want.
Gives an error.
Okay.
Not interpretable as a factor.
Okay. Does anybody else have a different answer? Okay, I'm going to go ahead and run this. So I didn't get an error. Okay. So do bear in mind, though, that when you're first starting, there is a good chance that when you get an error, you might have mistyped something. There might be an error in something you typed. So I would go back and I would double check to make sure that there isn't a typo somewhere in here. Because actually, yes, you can have a data frame that only has one column. And so if I do the view command, if I come over here and I say view my df, I can see that it is a data frame and it's got one column. Does anybody know the other way to view a data frame in RStudio without having to actually explicitly type out this view command?
Can we use a $sign after that and then type the word we want? I'm not sure. But...
You can. Well, actually, we'll get to that in a second because that's a way of accessing the data in a data frame. So another way to actually view your data frame as kind of this Excel style like this, another way to do that in RStudio is to actually just come over here to where your data frame is in your environment panel and just simply click on it. So if I close this and I do that again, just going to click on it and there it is. You can actually see that what's happening when I click on that is that it's actually running that view command in the console, but I don't have to type it in. So that's kind of a nice trick. It's sort of a shortcut to get here. All you have to do is click on it. Okay. But the rest of the data included their grades as well. So let's go ahead and add that in. Now, we do have to separate these with a comma because R doesn't know where the first column ends unless you tell it, okay, I'm done with this column. I'm moving on to the next one. All right, so we'll go ahead and add this in. And we have 98, 95, and 82. 98, 95, 82. So if we run this again, we can see now it says we've got 3 observations and 2 variables, which is just another way of saying features. So if we go ahead and view this, we can now see we have our students and our grades. And this is not too different from how it looks when you do this in Excel. Okay. Okay, I want to just really quickly point out the question in the chat because it's a fantastic question, and I think that Aola and Simon have given really good answers to it. So I want to make sure this gets in the recording. So Parhar asked, how will that be different from a list or a vector? And that's a great point because it's kind of like a collection of vectors in a way, or maybe a collection of lists in a way. So Aola says in a list or a vector, you don't have rows, whereas in a data frame, you have rows and columns, which is absolutely, that's functionally absolutely right. Because when you've got a vector, like let's say that we just isolate this by itself, and this is our vector here, this can only store data in kind of a straight line, right? So we can access any of the elements of this vector, but it's not two-dimensional. It's not multi-dimensional data in a sense. We can only know what the names are. We don't have the grades associated with them. And let's say we wanted to add another column, which is, something like favorite, fruit, right? So if we wanted to add that, we could do that very easily here, but there's no clear way to associate this with this original vector if we don't have it stored all together in this nice compact data frame format. So it keeps your data together. You could, in theory, have it separated in different vectors, but that would be kind of a miserable way to work with your data. Okay, so Simon says a vector is one-dimensional. Yep. So it will only contain a certain number of elements without being structured like a table. A table is two-dimensional, but each element, it can be a different length. A data frame is always rectangular. Each observation has the same number of features, and each feature has the same number of observations. And that's a great point, because if I attempt now to add another student here, so if I try to add, I don't know, Jason, now we can see here that I now have 4 students, but I only have 3 grades, and I only have 3 favorite fruits. So what will happen when I try to run this? Does anybody know what that will do? So you should be running this, right? If you've got RStudio up, go ahead and run this yourself and see what happens. That's the best way to test what will happen.
There's an error in the data frame.
Okay,
and
good.
It only shows information for the grades as well as the name only, not the favorite fruits.
Okay, awesome. Yeah, and I'm seeing, so you got that. A lot of people in the chat got that exactly. And let's actually take a look now. And in particular, the message says, and I think a couple people might have pointed this out. The message says, error in data frame, arguments imply differing numbers of rows. So this is going back to what Simon said. You could have vectors of different lengths, but with a data frame, the vectors that you're roping together here all have to be the same length so that you make like a perfect rectangle. Okay. Right. Differing rows. Exactly. Exactly. All right. So let's go ahead and fix that. Perfect. Okay, so now we know how to make a data frame. Let's talk a little bit about, oh, there we go. Let's talk about how you actually access one now. Right, so let's say that we want a particular observation and a particular feature. So we're basically going to ask the question here, what grade did Susan get? And the way we ask that is by using the numerical indexes or indices of the row and column. Okay, so that's kind of a heavy concept, but basically all this means is that we're trying to specify a value in a particular cell in our data frame. In this case, we're trying to say for Susan, who was the third student, what was her grade? Grades being the second column. So third observation, second feature, third row, second column. That's the way we'll typically denote that if we're using numbers. There's other ways to do this, but this is probably the most basic way to actually get that information. Okay. So let's go back to our IRIS data set now. You don't actually have to specify a column. You can actually just specify the row, put a comma, leave it blank for the column, and it'll actually grab the entire row. So let's go ahead and grab the whole first row of IRIS. If we go back to our IRIS data frame here, we can see that this is in fact our first row. They match up. And again, this was just running line 14. So instead of specifying a column here, we specify just one row. We can also do the same thing with getting a column. So let's say we wanted column 1, but we wanted all the rows that are in the data set. So basically we're saying, let's grab the entire column for the whole data set. We can just leave the row blank. And if we look at our data set here, we can see that, in fact, this is the whole first column. So it starts with 5.1, 4.9, 5.1, 4.9 in order all the way to the bottom where the last value is 5.9, 5.9. Can anyone tell me how I would get from IRIS the value in row 1, column 2? Okay, good, good. Yeah, Adam says, I'll just show you here. Adam says, which is absolutely correct. Yes. So row 1, column 2. Row 1, column 2, 3.5, 3.5. Finally, let's talk about the alternative ways to access data. So another way to access data is to use the $sign. So the $sign is a way of grabbing an entire column and returning it as a vector. Okay, so we'll see what that means in a second here, but I'll actually show you the example now. So let's say we wanted the grades column from my_df, which contains the students and the grades. We would just use the $sign, put grades afterwards, and that's going to access the entire column. Okay. Let's look at IRIS now. Let's say that we wanted to access the entire petal length column. It's pretty easy to do. You just add the $sign and then petal length afterwards. I just want to show you something that might not be apparent from this, but if you're in RStudio, if you just put the $ after Iris, you can see it starts giving you suggestions. So you can just click on the one you want, or you can use the up and down arrows to select, and then just hit enter when you're on the one you want, or you can click on it. Doesn't matter. It's a nice shortcut if you can't remember what all of your column names were, but you want to do that. Okay. So the last question here is, how would I get the species for row 3? Using this method that I've just shown you here, how would you get the species but get the value specifically in row 3? Okay, but yeah, okay. So Romina, that is a valid way. But I wanted you to use the $. I wanted you to use it. I know I didn't make that as clear as I should have, but I wanted you to use the $. But yeah, that also works. So Romina said 3,5, which would give you the 3rd row, 5th column, which would be correct. But the way I want you to do it, that Adam said here, is to do iris species and then the 3rd one. Okay, we didn't talk about factors. That's what you're seeing here. Don't worry about this for right now. If you don't feel comfortable yet with factors, I think that you'll probably find that it doesn't end up coming up until a little bit later. So just for right now, don't worry about this. Okay. All right. So we did the same thing here where we took the grades column. We wanted to ask the question, what grade did Alice get? So that would be the 2nd observation in the grades column. So that was just grades brackets 2. And so we got the grade that Alice had. And that's it. There's one final way, which I didn't mention. I'm going to briefly just show you here. You don't have to use the $. You could instead use, let's say I wanted that 3rd row and I wanted the species column. I could have used species like this instead. That's another way, but it's one that I don't really use and I don't know anyone who uses it. So I just thought I would mention it, but not make a big deal out of it. I'll put that in the chat in case anyone is wondering. Okay, and with that, let me go ahead and turn things over now to Aola, who's going to talk to you today about programming in R. So Aola, you ready to go ahead?
Yeah, let me go ahead and share my screen. Thanks, Henry, for going over that.
Yeah, absolutely.
And then if everyone, I'll give everyone a quick minute to just go to the module 3 in the Git account file that you downloaded earlier. And while you're doing that, I'll go ahead and share my screen. So I have dogs, so if there's barking in the background, sorry about that. Okay. So is everyone in module 3? Okay. So I'll go ahead and start and just assume that everyone's already in there. So yeah, we're going to go ahead and start module 3, and we'll just be going over the fundamentals in R. So a lot of these concepts are very common in different types of languages. So even though the syntax is different, sometimes just the logical concepts of how the program reads these fundamental programming concepts are very similar in other languages. So it's beneficial to know how R works, and then it can kind of translate to some other languages in a lot of these different functions and flow controls. So starting off with where we're at now, that we had Henry's data frame structure lesson, that was a little bit of a bleed through from data structures. We're going over our fundamental programming concepts, and 2 weeks from now, we'll be having a review week, where after that, Simon will be going over the tidyverse and R for biological data scientists. So starting off our lecture, we're going to go over flow controls first, and flow controls are anything in your code that it adds efficiency to your code. It makes it easier to read and it saves you time overall. And what I kind of mean by that is eventually at some point when you're going to be writing your R script, what happens a lot is you find yourself copy and pasting a lot of your code or writing it over and just tweaking it a little bit. And it ends up taking up a lot of your time to keep writing your code and to copy and paste. And usually when you find yourself doing that, it's an indicator that you might be able to use a flow control. And you can make your code easier to understand, and you can save yourself time by not writing it all over again. One of the flow controls that we're going to start off with is if statements. So if statements are used whenever you want your code to have one of your code run only on a certain condition. So let's start off with part of our data structure lesson that we did 2 weeks ago. For example, we have our variable x is 42. And when we ask R whether x is greater than 0, what we get back is that the logical true. And that's because our variable x is greater than 0, it's 42. We can use that concept in our if statement. So we can ask R if x is greater than 0, which should be evaluated as true. Only then do we want to run our next code and print out positive number. So the syntax here is if, and then we put our conditional statement, and the code that we want to run is put into these 2 brackets. So you can tell here that it's within the if statement because it's slightly indented. And so you can know that once our statement is evaluated as true, it'll print our code or say positive number. Let's say that it prints out false. As in the next example, we'll have now x is negative 42 as opposed to 42. And if you had tried to run x is x greater than 0, it'll bring back false. So in our statement now, we'll have the same exact code where we ask if x is greater than 0, print out positive number. But in this case, x is negative 42. And when we ask x is greater than 0, it'll come back as false. And it actually won't run our next line of code that's within these brackets. So that indicates to you that your condition was evaluated as false and your code was not run, your if statement was not run. You can also do that in a logical context. So you can ask your condition using a logical. So now we'll change our x variable to 3. And we'll say, is x 3? And that will be evaluated as true because now our variable is 3. So we have the same syntax, but now our condition is a logical. And we're asking it, is x 3? And it will be evaluated as true. And in that case, we'll print out our command that we want, print x is equal to 3. And the output will be x is equal to 3. But if you remember from our data structures class, we can also utilize the not statement, where we can say, we only want our code to run if x is not 3. And in this case, that x is not 3 logical will be evaluated as false, in which case our code will not be run and nothing comes out. So that's a quick introduction into if statements, and what can be negative in this case is you don't really, if you want more control, you don't want your if statement to just end. You want to have something happen after your if statement is run. If it's run as false and nothing happens. Sometimes maybe you won't know whether your if statement worked at all, and you want to make sure that something happens even if your statement is evaluated as false, in which case you can use else statements. So the else statement runs within your if statement, and only if your if statement conditions are false. So in this case, we'll go back to a numerical condition and say our x is back to 42. So now that our variable x is 42, and we're going back and asking, is x greater than 0? In this case, x is greater than 0, so this first part of the statement will be evaluated as true, and our first condition, our first code line will be run in this if statement, and we'll get back a positive number. The else statement is also in here, but it's not run because it was already evaluated as true under this first line code. And so the else statement is ignored. But let's say that now we have our variable y, and we have the same statement, or the same if statement, but this time we're asking is y greater than 0? And so in this case, it will evaluate as false, and only our second line will be run, where it says, now that the first if statement is evaluated as false, ignore that part and only run our else statement, which is negative number. So something to consider here that's important is, again, the syntax. So notice how my first code that I want to run under my first condition is within these first brackets. But the code that I want to run under the else condition is within this else bracket. So you want to make sure that where your code that you want to run within the statements, your else statement or your if statement, is within a specific set of brackets. So now we'll do the same thing, but using a logical condition. It's the same as earlier, but now we're utilizing an else statement. In this case, our x is back to 42. We're using the x variable is now 42, and we're asking, run this set of code, print x is equal to 3 only if x is 3. So if this first part of if statement is evaluated as true, it will only run this first part of the code. And since x is not 3 and this part is evaluated as false, we're only running the else statement. And we're saying x does not equal to 3. So that was a lot of information. Does anyone have any questions? Okay, so Manish asked, does the indent matter? So that's a great question. The indent actually, if you're doing the brackets correctly, the indent is automatically put into R. So you can actually try it yourself. If you just rewrite, the code that's in there should be a part of your R project file. There should be also just an R file, R script. So if you open that R script, you'll have the same accompanying code that I'm going through today. And in that R script, you'll have this code run in there, and you can just type it out yourself. And you'll notice that the indents will go through R automatically. All right, so now we've gone over if statements and else statements, and that gives you a lot of control over your code and your data. But a caveat to the else statement that I already mentioned, which is a great feature, but can also be negative in the fact that you want more control over your code, is that the else statement runs no matter what if your if statement is false. What if we want to have more conditions in our code? That's where the else if comes in. If you need more conditions into your code, then you can utilize this syntax and this statement of else if, where you can add actually as many else if as you want into your if statement. So we start off with our variable. This is now x equals 0. And we have our statement that starts off with if x is 3, then we want this first line of code to be run. If x is 3 evaluates as true, and we want to print x is equal to 3. However, if this evaluates to false, we want the next line of code only if our variable is 0. And if that is evaluated to true, we'll have our second line of code run. If both of these lines of code is evaluated to false, then it defaults to our else statement. And it will run the else statement only if these two primary statements are false. In this case, x is 0, so our second else if statement is run, and we print out x is equal to 0. Okay, so does anyone have any questions on else if or anything else that I've gone over? Okay, so we asked what the difference is between just one equal sign and two equal signs. So in R, there's actually two different ways to create a variable. You have, here I'm using x equals 0, and so I'm creating a variable where I'm putting 0 into the variable x using this equal sign. You can also use an arrow sign. So you can do, if you do in a Windows computer, Alt and then minus, after a variable, you'll get an arrow sign, and that will also assign a variable for you. But if you do equals equals, it's indicated as a logical in R, so it will evaluate whether your variable is 3, and it will return either back true or false. So that's a difference between these two. I'm just using this equal sign here to assign a variable. And you can use else if multiple times. So let me 1 second, let me reread that. Yeah, so you can use else if multiple times if you want multiple conditions. So I can have 2 or 3 conditions in here. The only thing you have to make sure to keep track of is making sure that the code that you want to run within your else if is in the correct indents. Okay. So now we've gone over if statements, and we've gone over our code if we want our code to run only under certain conditions. Let's say now we want our code to run over an iteration. So we want to create a code that loops over a certain feature or vector. And so we'll start using the loops in our code. So loops in a programming language iterate over a number of elements in your vector. So for example, we have our numbers vector where we have the elements 1, 2, 3, 4, and 6. And in this numbers vector, we want to go over each of these elements and print them out individually. Now we can do this by just saying print numbers and then print the first element in our vector. Or we can do this by typing out and saying print numbers in our second element, then typing it out again, print numbers in our third element. And if you remember, this can be an indication that you might be able to use a different type of flow control in your code instead of having to type out, print, and then numbers, and then a different element each time. So in this case, for loops can be really beneficial for us. And this is the syntax we're using a for loop. So what's happening in this syntax? What are we basically trying to tell R to do? We'll start off with our numbers vector. As you notice, we have our numbers vector assigned after the in. So we're saying for var in numbers. So for our numbers vector, our code loops back to our vector and notices, okay, you're asking me to go back to the vector that you just made. And it goes over the first element. This first element is put into this empty variable that we created in our for loop. So it goes into our vector, gets the first element, puts it into our variable, and then it asks, what do you want me to do with this first element that we now have in our variable? And the code that you want to run with that first element is written between these two indents. And all we want to do is for it to print the value that's in the first element. So we're asking it to say print var. And then it does the same thing with the second element. Goes back to the numbers vector, puts in the second element into our empty variable, and then it runs it again through our code of interest. And then it goes back to third element, puts it into our variable, and then prints out our third element, and so on. So what we get as a result is our printed numbers, all printed individually from our numbers vector. So before I go into a different way to write for loops, does that make sense to everybody? Okay. Perfect. So we'll go over just a different method to write a for loop. So we can utilize indexes within our for loop function. So this will return, as you can see, the same output, but we're asking it in a different way. Sometimes with for loops, you need to be very explicit to get the exact results that you want. And it's good to practice just different ways to write a for loop. So in this case, what we're doing and what an index means is we're taking our numbers vector, but now we're asking it to go over the elements specifically. We want just the element number, not the element value. So what do I mean by that? So 1 to length of numbers. Let's go back to our numbers vector and figure out what 1 to length of numbers means. So here we have our element values, but we're asking for the length of our element. So instead of getting back, as in this for loop, instead of getting back the number 1, 2, 3, 4, 6, which is the actual value in our vector, we're getting where that element is located. So we're getting position 1, position 2, position 3, position 4, and position 5. And that's what's being stored now in our var empty variable. Instead of the value of our vector, we're actually storing the element location or position. And so now we're saying print numbers position 1 or position 2. And then it extracts the value from that position and it prints it out explicitly. So if you'll notice, this looks extremely similar to what we were printing out earlier, where we had to do it individually. So now we're doing the same exact thing, but using our for loop variable var. And you get the same output here. So that's just a different way to write our for loop, but getting the same results. So now we have gone over for loops and how to go over each element specifically in our vector. But let's say that we want to amend our loop, or our variable, every time that it goes and loops over. And let's say that we want to end our loop only on a certain condition. So we can go over while loops, which utilizes amending our variable, and then you can stop our loop in a specific condition. So what do I mean by that? So here we have our variable x is 1. And notice how now I used a arrow, and previously I was using an equal sign, but this is the same thing. We have our variable x is now 1. And we're running a loop, and this is the syntax of our while loop. So we first have while x is less than 6. We want to print, and then paste means that it's just constantly, every time that it loops over, putting out the same output, x is equal to, and then we want to print our x variable. Every time that we loop through this x variable, we want to amend it by adding 1 to the x variable. And we want to do this, like I mentioned, only under this condition where x is less than 6. Once we get, now after amending it throughout the loop, once we get x is 6 or greater, and once this condition is evaluated to false, we want the loop to end. So the output from this while loop is x is equal to 1. So this is the first time that it goes over our x variable. And then the second time that it goes over, it'll add 1 to it. And then now x is equal to 2 in our while loop. Then it goes over our, now x is equal to 2. So it changed our x variable to 2 within this while loop. And it'll go back and add another 1. And now x is equal to 3. It does that until x is equal to 5, and then it stops. Because after 5, it adds another 1 after going back, and now x is 6. But in our while loop, we indicated that we want the loop to stop once x is equal to 6 or greater. So notice again how the function that the code that we wanted to run was within these 2 indents. And another thing to keep in mind with the while loop that's very important is that we did amend our variable. And if we didn't do that, then this while loop would go on forever, and it might crash your RStudio session. So what you want to do is always make sure that there's a way that you have your while loop ending. And in our case, we amended it with adding 1 each time that it looped over. But if we didn't add this 1, it would just continue saying x is equal to 1, x is equal to 1, x is equal to 1. So that's something to keep in mind when you go over while loops. So now that we have gone over loops functions, which we have gone over how to get more control over your R code and your data. But let's say that you want to loop over your variable or your vector, but you want to skip certain parts of your vector, or you want your specifically for loop to end after it reaches a certain part of your vector. And that's where break and next statements come in. So talking about break statements to start off with, we'll have our numbers vector again, and we're going over a for loop. But notice how this time we're also utilizing an if statement within our for loop. And what we want to do, and what we want to tell R, is go over each one of these elements in our numbers vector, but I want you to stop at 4. So this is similar to the while loop in the sense of we're looping over and we're going over each element and we're breaking at a certain point. But instead of amending the variable, we're just reading over the variable and we're going over and asking it to go over our with this code. So going over this for loop, we have our numbers vector, and then it goes over our first element and it gets the value, since notice how we didn't use an index in this specific example. It gets the value of our vector 1 and it puts it into our empty variable. And it first goes over this if statement where it asks, is this value 4? And if this value is 4, then it will print out the variable 4 should not be there exiting. And you have the break statement where it indicates you want to break the loop. But because our first element's value is 1, this will be evaluated as false, and it won't run this if statement. Instead, it'll go to our for loop code, and it'll only run this code, this line of code. It will say print, and then just repeat this specific characters, and then print the variable content. And so what you'll get is the values are first element, or first value, 1, and then values are 2. And then when you finally get to when your if statement is evaluated as true, what happens is it does run this if statement, and it stops the code, and it doesn't run our next line of code. So it'll just print out the variable 4 should not be there, exiting, and end the code. However, if our if statement was never encountered, as in our next example where I changed 4 to 5, and we have the same numbers 2 vector, but instead with different variable elements, and we go through the same exact code, but this time it doesn't run into our ifs and break statement, and it only runs our second line of code, and it never breaks. The loop continues. So in this case, we just completely break our for loop, but let's say that we don't want to have our loop end. We actually want our loop to continue over all the elements, except maybe a specific element that we don't want to include in our code. So the difference between, and let me just really quickly say that for break statements, they can be, for example, used as maybe verifying that your code, it's almost, you can use it as a kind of error. So you can go through your data and you can say, for example, if this certain variable or if this certain value exists in my data, then just don't run the code, and you can realize that a certain value is in your data. And so that can be where break statements are important. But yeah, if you want to run your entire vector and only want to skip over certain elements, the next statements can be really beneficial for you. So in this case, we have the same vector where we have numbers, and you have 1, 2, 4, and 6. And you have the same syntax and similar code, but instead of having break, you have next. And what this is saying is you're going over through every element in your vector. So you go over element 1 in your numbers vector, take the value of that, you put it into your var variable, and you say, is this variable 4? Is it equal to 4? And if this returns true, then it'll print the variable 4 should not be there, and it'll go to the next element, and it would skip. But since this is the first element is 1, and this is evaluated to false, it doesn't go through this first line of code, and it only goes through your second line of code where you have similarly values are, and it just prints out your value on the first element. And it does so until it reaches where it actually evaluates as true. And you have 4, and whether that is 4 or not, once that evaluates to true, it'll skip that particular value, or it'll run through what your code is. And then it goes ahead to 6. So this is different because you're going through each element in your vector instead of just ending your loop. So we go ahead and I'll just give a quick challenge question. Like I mentioned before, the indents are very valuable in your for loops and your if statements. So what happens if I change here? Previously, I had my print paste values are var on that in this second indent over here, and I just moved it a little bit forward. That's now within this if statement that utilizes next. So if you have the RStudio open, you can just go ahead and run this, or if you already know, just put it in the chat. Okay, perfect. Yes. So the only thing that this will return is the variable for should not be there, but the rest of your code is not run. So you don't see the values are, and you don't see that being run for your first element. You don't see that being run for your second element. And the reason for that is because now your print paste values are var code is within this if statement. So the only thing that this if statement is evaluating is if the variable is 4. And once it reaches the true function, then it'll go over and run the code of interest. But it won't go over the next set of code because it's within this if statement. So that's why indents are important. It can really depend on where your code is within the indents. And sometimes when you have a for loop that you're writing down and it's not giving you what you want it to do, that's one way that you can kind of troubleshoot, is just look at where your code is within the indents and see whether that matches up. So now we're going over loops and if statements and a lot of different types of flow controls. And the next thing that I want to switch gears to is talking about functions. So I'll first do a quick review of what we had in our data structures class from the last workshop. Before I do that, actually, I want to go over and make sure that no one has any questions. So if you have any questions, just go ahead and put it in the chat. Okay, so if the vector doesn't, if it says, for example, you have something that says your vector isn't found, like number not found, what that can mean is you might not have inputted the numbers vector. So if you go back and you just do Control Enter of numbers and then your vector, that should give you the variable, and then it'll continue with the rest of your code. Yes, so the correct code for the challenge question earlier is actually what was previously. So this was the correct answer. And what I did for the challenge question, let's say I had accidentally messed up and gone back and didn't check exactly where my indents were, I instead put this print function right behind next. But for it to work, you need it in the indents that's within this for loop. So it's right behind this first indent over here. So if you'll notice, this is the indent for the if statement, and then this is the indent for the for loop. So this will be run over each element, whereas this indent over here will only be run for our if statement here, where it's only going to be evaluated when our var is 4 is true. Okay, so I'm going to go ahead and go over functions. And so just as a quick recap based on what our previous workshop was on data structures. So functions is anything that we have an input for or an argument and that R produces an output. So for example, we go back to having our numbers vector, and whenever we do print numbers, that's already an example of a function because we're taking our input numbers and we're outputting or printing out the numbers vector. And the structure of numbers is also a function because we're taking our argument numbers or vector and we're asking it to output the structure of our vector, which is a number with a 1 to 4, and it has the elements listed. Same with creating a sum of R vector or a mean of R vector. So those are all examples of functions. Whenever we want to read a table or a file into R, or whenever we want to write a file out of R, that's also an example of a function. So for example, we'll start with a read.csv and a write.csv. In read.csv, we put in our read.csv function, and our input is the file that we want to read into R. And that should automatically be pulled up for you based on the R project. All the files should be included in your R project file. And we're storing this file into our data table variable. So now data.table contains our file, and that will be read in as a data frame. We can also create a data frame. So we can create our data frame that we have here, and we can write it out as a CSV. And a CSV, again, is a comma separated values file. So it's what's read by, for example, it can be an Excel file, and you can format that and write it out as a comma separated value file and then read it into Excel, for example. So here we have the data frame, and we create it with a data.frame function. And then in these parentheses, we have our first column, X, is equal to, and now we create our first column with the sequential numbers 1 to 5. So you'll have 1, 2, 3, 4, and 5. And then in our second column, Y, we have 3 to 7 sequentially. And we're storing that data frame into the variable my.df. And to write that data frame out, we can do write.csv and then in parentheses have my.df, which is our variable that contains our data frame that we just made, and then separate it. And the next argument that we're putting in is the name that we want our CSV file to be. So it will be bioinformatics_data.csv. So that will write out in your environment your bioinformatics data.csv file. So I'll actually go ahead just really quickly and go to RStudio since I think it might make more sense. Okay, so here we have our original function that I just talked about. So we have our data.table, and we're actually trying to read in a CSV file. which is the bioinformatics.csv file. And we do that with the function read.csv, and we pull it up with these quotes, bioinformatics.csv, and that's the file name that we want to read into R. Once we do that, the data table will actually pop up on our global environment. So once we read it into R, it'll pop up here, and you can either do it with a view and then .data table, or you can just click on that and you'll see the data table that we just read in from our file. And you can also print it out on your console by just doing data.table. To write a file, so let's say that we have a data frame that we created by data.frame with a column X and column Y, and we're reading that into a variable my.df. So once we create that, we see our now created data frame into our global environment my.df, and that you'll see that it has the column X and column Y and the rows containing the values that we inputted. And we can write that file out of our R environment into a comma separated values file by doing write.csv my.df, which is the variable containing our data frame, and then the name that we want to assign to our data frame. Once we do that, you'll see your data frame in your file location. So you'll see bioinformatics_data.csv, and that's the name that you wanted to assign in your write.csv function. Okay, so before I go into the challenge question, does anyone have any questions on those?
Yeah, can you repeat that? It was way too fast.
Oh, sorry about that. Okay. So the data, so we're going over how to read and write CSV functions into our environment. So we're going over how to read files into our RStudio environment and how to write them out of our RStudio environment. So let's say that we have a comma separated values file, which can be just an Excel file. So if we have an Excel file and we want to read that into our R environment, we use the function read.csv. And within the read.csv function, the input is the file that we want to read in to R. So for example, we have read.csv and we have an Excel file that's called bioinformatics.csv. And that is read into our variable data.table. So I'll just go back to our RStudio one more time. And we'll see here, I have my bioinformatics.csv file, which is right here. And so if you remember, when we're looking here, everything in here is in a specific folder. It's where you just downloaded your module 3 from GitHub. You'll actually see this in your folder, and you can actually open it up yourself using Excel. And you can open it up using Excel even in R. So, or yeah, actually you can just view it. You can't open it through R, but you can open it in your file. So you can either view it as its original format as comma separated, or you can open it with Excel where it will assign it automatically into the Excel worksheet. So this is just a file that's in your environment and you want to read that into R. So the reason why you would want to do that is because maybe you want to manipulate your file, you want to arrange it and read through the data using R. So to do that, you did read.csv and then you just pull up your file. And when you pull up your file that's already in your environment, it'll find it in your environment so you can start typing it up. And then if you press tab, once you start typing up the beginning of your file, it'll pull it up for you, and you can just do enter and it'll automatically fill it out for you. So once you do your file within your argument, you just do read.csv and it puts it into this data.table variable. And you can print that up with doing just data.table, or you can pull it up in your global environment. So does that make sense so far?
Yeah.
Okay, so then if you want to write a file, let's say you have a data frame that you created yourself within your R environment. So we, for example, created a data frame, and we made this data frame using the data.frame function, and we created column X and column Y with the values 1 through 5 and 3 till 7. And we assigned that to the variable my.df. So we created our own data frame within R, but now what we need to do is to write it out of R. So in this first function, we were reading data into R. In the second function, we're writing data out of R. And in order to do that, and the reason why we would want to do that is because we want to be able to send the file, for example, to somebody and to have them easily open it in an Excel, for example. And so we just do write.csv, which is the function to write our file or to write our data frame. And we do the data frame that's held into our variable my.df. And we have, so this is the first argument. And then we have our second argument, which is what we want our file name to be. And that is bioinformatics_data.csv. And once you write that out and press enter, it will automatically put your file in your file location, and you can actually find that in your file location. So if you go into your module 3 file, it'll just show up there for you. Okay, so hopefully that makes sense. So I'll go into our quick question, a challenge question, which is an aspect of data frames that Henry touched on. Notice how in our data frames that we read in, so for example, in our data.table, we have the same number of rows in each column. And in the data frame that we created, my.df, we have the same number of rows that we created. But let's say that you have an Excel file as a comma-separated value file that does not have the same number of rows. So it might have some rows missing in column X, for example. So maybe we have row 4 and 5 missing in column X, but column Y is filled out completely. So what happens in that case? So I'm just going to go over this since we're running a little bit short on time. If we read in an Excel file that doesn't contain values in or has missing values in certain rows of one column, but has completed values in all the rows on the second column, what ends up happening is that those rows that do not contain values in the first column is filled in by R with an NA. So that's something to consider if you're reading in an Excel file or a comma-separated value into R. Sometimes you might introduce NAs into your data frame. So now we've gone over different types of functions, how to read and write your functions, and those are all intrinsic functions within R. But what if you want to make your own function and have more control over what your code wants to do? in R, you can actually create your own function by using a function to create your own function, function x. So let's say you are doing function x, and then within the function x argument, you have a value of y, and then you want the value of y to be squared. So what you want out of this code is you want to input a value and you want it to square it. So you want to input 5 and you want to do 5 squared, or you want to input 42 and you want to do 42 squared. So to do that, you do your variable square it, and then you can do function x, and within these indents, you do have what you want to do within the variable that you're putting in. So for example, you have 5 and you want to put in 5 and you want to change it to 5 squared, and you want that new value to print out the square of and then the first value that you put in, and then you want to print out is, and then y is the value that you're changing it to. So that's a little bit confusing. So for example, we're putting in square it, and then this is our input x. So function, this is what we're putting into our function. And what we're getting out is our output y, which is our input x squared. And that's printing out as the square of our input x, and then is, which is just pasted, y, or which is our output. And our result finally is the square of 5 is 25, which is 5 squared. And you can input any value of x from there. So for example, our value of x now is our input 42, where our variable is square it, and then our input x is 42, and it runs the rest of the code as 42 squared. And the output is printed out as the square of x, which is 42, our input, is 1764, which is our output, x squared. So that's a little bit, that's a lot to go through. Does anyone have any questions on functions? Yes, so you would have to save, so if we create a function and we say square it 5, for example, we have our input and we want it to square our input of 5, you would have to save this input in a variable in order for it to be saved. So it'll get printed out, but in order to save it, you would have to save it in a variable, or you could create a data frame out of it. So in order to save it and to print, and to keep your function, you would need to either save it into a variable or read it out into a data frame, or something like that. But right, it will be kept in your script, right? Okay, so we'll just quickly, since we're running very low on time, we'll just go over apply functions really quickly. So apply functions are kind of putting in together both the for loops and if statements together, in the sense of for loops and functions together in the sense of we're iterating across different vectors or data frames, but we're also using a function. So what that means is we'll start off with what the types of apply functions are. So we have just apply, which goes over specifically data frames. We have lapply, which goes over lists or vectors. And then we have sapply, which goes over lists and vectors similar to lapply, but the output is slightly different. So we'll start off with just an apply function. So let's say that we created a data frame and we have a data frame with column X and Y and with 5 rows. And we want to calculate the mean in each individual row. We can try that with a for loop where we would have to index each specific row and say, okay, I want to go over row 1 all the way to row 5 and get the row number specifically in our data frame and hold the row number in our variable, empty variable. So in this case, we're saying, let's go over and iterate to our first row. And that's get the first row element and then get the second row element and hold that into our variable, empty variable. And in that first row element, we want to print out specifically just the first row. And this is going over the X. So like what Henry mentioned, we had the first row and then comma. And then if we had something else in here, it would indicate the column, but with just the first element and then comma, it's the row. And then we want to get the numeric numbers in that row and then calculate the mean within that row. And we hold that into the variable myMean, and we want to print that out. But to use it in an apply function, it's a lot easier in the sense of we can take our data frame, which is stored into the variable my.df2. We can get the first row of our data frame and we can calculate the mean. And this is the function that we want to go over each of our rows. And it prints out the same values. But as you can tell, it's a lot simpler to write out. It can be a lot easier to read and manipulate. So apply functions can be valuable in being able to shorten your code and to be easier in manipulating your data frames. lapply goes over specifically just lists. So in our example here, we have a list of X, Y, and Z. And we have our vectors X, Y, and Z, and we're creating a list of X, Y, and Z, where in our first element, we have vector X. In our second element, we have vector Y. And in our third element, we have vector Z. And we're using the function lapply to take the minimum of each vector in this list element. So we'll say that we want to lapply to read through the list LIS and take the minimum of each of the vectors within that list and to print out those minimums. So in this case, the first element minimum is 9, second element minimum is 3, and the third element minimum is 18. And you can print out the structure of our listmin using our structure function. And sapply is doing the same thing as lapply, but it prints it out in a different output, tries to simplify the output for you. So instead of having the minimum in each element that we had here, so this is first element X, Y, and Z on the second and third, it just prints it out all of the minimums for you. So it doesn't organize it the same. So this can be kind of confusing sometimes depending on what you need for your code, but it just depends on what you want to do. So there's different ways that you can utilize apply functions. And just really quickly, I want to go over our which function, which can be very useful in extracting data from a data frame. So for example, we'll have a data frame that's including a vector of ensemble IDs, of gene symbols, and of entras IDs, all corresponding to each other. And we create a data frame from these vectors, where we have our column entras equals our vector entras. So right here. And our column gene symbol is our vector gene symbol, and our column ensemble is our vector ensemble. And these create a data frame that's held into my genes variable. And this is what that data frame looks like. Let's say that we wanted to specifically extract this variable into that's in our data frame. So we can do that by using the which function, where we say which and then our argument. Wherever my genes, which is where our data frame is, and then specifically in our ensemble column, what row is this value in? And so it extracts the row 3 because that's where our value is located. So this just extracts the row number. So again, we're going over my genes in column ensemble, and we're asking it to evaluate where this specific element is true. And this is pulling out the row number of where this ensemble ID is located. So this can be powerful because once you get your specific row number where your ensemble ID is located, you can actually extract your whole row. So in this case, you can do your variable my genes, which contains our data frame, and you can get the row number in the first column or in the first in the first element, and then do comma and then keep it empty to indicate that you only want to extract the row. You don't want to extract just the column. And that will extract out the whole row for you, which is where our variable that we searched for with the which function originally came from. So I went through that pretty quick because we were running out of time, but does anyone have any questions before we end the workshop today? And right, again, like as Henry said, we will have this in our online bigbioinformatics.org. Okay, great. Well, if there's no questions, I'll just go ahead and stop sharing. And thank you everyone for being here today. I really appreciate it. And I'm excited to do our review week for next time and go over what we've already learned today.
All right, great work. I just wanted to quickly say before we sign off here, if you haven't already, do make sure you do the intermediate data camp. I'm looking at the stats here, and I know not all of you have done it. So do please go do that, and also do the R programming assessment. So it's just paramount at this point that you have to get that basic knowledge. The part of the course that we're in right now is the hardest part by far. And getting past this point means that you'll get to sail nice on through into tidyverse and enjoy your R future. But this is the point where I'd say it's critical that you go and you do that foundational component. So I'd go back, do the data camp, do the practice problems that are included with today's lecture, and we're going to do a recap next time. And I think at that point, we'll be able to take questions and make sure that everyone is feeling like they're on the same page with this. But yeah, so if you feel frustrated right now or you feel lost, that is expected because this is the hard part. So just do bear that in mind. Make sure you go back and do the data camp. And we're also happy for you to come to our office hours as well. Those are posted in the syllabus. So do feel free to do that as well. But yeah, all right. Thank you, Aola. And yeah, looking forward to doing the recap next time.
Yeah, thanks, Henry. Thanks, everyone.